I talk to mining executives and CEOs around the world, and almost in every case they ask us, where are we with autonomous vehicles? And the reason they're so interested in that is they see that that's going to help them in so many ways. Autonomous truck requires 4.5 operators to operate that truck over a 24-hour period of time due to the shift changes. With autonomous vehicles, you don't need those operators. It lowers their costs because they have fewer people at the mine site. So this is a very important innovation for the mining companies in the future because it improves their productivity and utilization. It lowers their operating cost and increases the safety of their mine sites.
This is definitely the way for the future. For Caterpillar, you minimize every single element and you could actually centralize the control to one operation center and you could literally mine the whole project from multiple sites.
This is completely different than anything that we've ever done before, and I'm happy to be part of it. Caterpillar is always making sure that they are cutting edge, and that we're doing it again here with the autonomous truck.
Autonomous vehicles will give us a significant competitive advantage, not only in the fact that we can provide products that provide more value to the customer, but this also requires building closer relationships, greater trust, and confidence between the mining company, the dealer, and Caterpillar, because we rely on each of us to be successful. So this really forges an even stronger bond of trust and confidence.
as you can see on the screen, we have Montana Tech on the left side of the screen, and we have Purdue University on the right side of the screen. Both teams have students in the arena and in the control center setting up for this run. Both of these teams performed very well in their first competition run. This is the second run and final run for both of these teams this week. The Montana team has chosen tracks for mobility, and they've chosen an end loader bucket and a conveyor in order to get that regolith into and out of their robot. Purdue team has chosen wheels, and they've chosen a plunging bucket ladder system in order to dig down into this regolith simulant that's in our bin today. These teams have spent all year designing and building these robots. So less than 3 minutes into this 5-minute setup time, the Montana Tech team is ready to go. They've already exited the arena. Purdue still has time. They still have 2 minutes to get their robot up and ready and operational. That's a rear view of the Montana Tech robot. You can see the tracks. You can see the in the middle of the screen, you can see the conveyor. It's a very wide, possibly rubber conveyor belt. And then at the top, you can see just the tip of their end loader bucket. One minute remaining of setup time for these teams. In the control room, both teams are working to set up their command and control systems, their computers, their laptops, their network equipment, their joysticks, their gamepads. Some of these teams drive their robots with joysticks or gamepads. Some of these teams drive their robots just using the keyboard on the computer. I've even seen some teams typing command lines on a command line. All right, now the Purdue University students are leaving the arena. Hopefully they had enough time during that 5-minute setup period to get their robot fully operational and communicating with the students' equipment in the command and control trailer. The students who are controlling these robots are going to be in these trailers outside of our tent. The only visibility they have into their robots is data that's coming from their robots and 2 camera views that we are providing them. We are about to start. Montana Tech on the left and Purdue University on the right are both about to start their second official competition run, their second and final competition run. They both had very strong performance, very strong scores in their first run. So this is going to be a really exciting run, I think, assuming that none of the robots run into any issues. And the green flag tells us that the competition has started. You can see motion from the Montana Tech team right out of the gates. They're turning their robot around, not having any trouble driving around in this regolith. Making their way across the obstacle field very quickly and very easily with those tracks. That tracked robot is not having any trouble. There you can see their end loader. You can see the front of their robot up in the air as they dig down deep. Boy, that's really deep. Now we're, wow. All right, now they're going to dump it into a little hopper on board. Let's see. They're going to do multiple scoops before they are done. On the right, you can see Purdue. They have made it across the obstacle field. But for a digging operation, they're turning sideways. Look at all the clear plexiglass on this robot. The teams actually get extra points for enclosing the dust. Dust encapsulation gives you some extra credit in this competition. And I would say Purdue University has quite a system for dust enclosure there. You can see the Purdue bucket ladder system spinning. You can actually see regolith falling out of the buckets into their onboard hoppers. So Purdue is definitely making good progress digging this regolith simulant that we have in our bin today. Again, Montana Tech on the left, Purdue University on the right. Both very strong teams in this competition. We saw a little bit dumped on the ground there by Montana Tech. Are they going to go back now? How many loads are they going to take on before they go back and dump it on the lander? They're going back for more. Look how deep that bucket is going down into the arena. You know, if they go more than 12 inches down, they could get some gravel, and that's extra points. I don't know if they're actually capable of extending down that far. Look at that pile of regolith on board. They totally are. This is real-time feedback from the crowd. They can go 12 inches down. That's no problem for them, I'm told. You can see they're still pushing down. The front end of the robot comes up off the ground as they push into that regolith simulant and dig it out. And there's a close-up of Purdue. You can see they're actually driving their robot slowly as they dig, digging a trench as they go, lowering their system a little bit, getting a little bit more of a bite. Now they raised it back up a little. I think Purdue, okay, both teams. Montana heading back fast. Montana's robot, very fast robot going across that obstacle field. Purdue taking it a little bit slower. All right, you can see Montana, they have a conveyor belt on the back of the robot that is going to convey that regolith simulant into the lander's hopper. Let's see how it works. Both teams, Purdue also heading back to the lander, but at a much slower, more. There's Montana Tech dumping their regolith. It just keeps coming out. Montana Tech. Just keeps unloading, keeps unloading. And on the right, Purdue University is raising their dumper. Let's see how much comes out of Purdue's robot. You can see it starting to slide. You can see through the clear plexiglass. And there it comes out. Still more, still more, Still coming out, still coming out. Very impressive by both teams so far. We are halfway through this 10-minute competition for these two teams. Their second of two official competition attempts. Montana Tech on the left. They have 17 kilograms in the hopper right now. Purdue University on the right, they have 10, almost 11 kilograms in the hopper right now. Both teams really performing well right now. Montana comes back into the digging area rather quickly. They're going to find, look at them lining up to that same spot. They're going to find that same spot and dig in deeper. They want to get 12 inches down so they can get a hold of that gravel, which is extra points. That gravel is simulating icy regolith that has frozen ice in it. That's the really good stuff. That's gold in our book. If we can excavate icy regolith, we can turn that into that. That's good stuff. So we give the teams extra points if they can get that gravel out of there. But it's buried 12 inches down. Down. There's a good shot of Purdue. You can see kicking up a little dust. That's okay. That's part of the digging process. No harm in kicking up a little dust. A very fast bucket ladder system. You can see it kind of binds up a little bit when they get a hold of a really good hold of that regolith simulant. It tends to bind up if you try and push on it too hard. So there's a happy medium that these teams, robots, have to find in order to dig. I don't think Montana Tech has to find a happy medium. I think they can just power through this stuff, no problem. Montana Tech's robot is looking like a well-oiled machine right now. Montana Tech is sitting at 17 kilograms in the hopper. Purdue University sitting at 11. This is very close, a very close race between these two teams. One team using an end loader bucket design, the other team using a bucket ladder system on a conveyor belt. One team driving on wheels with fairly large diameter, the other team driving on tracks. Both teams performing very well, even though they have very different robot designs. Montana Tech heading back to the lander. We have 2 minutes left in this competition for these teams. 2 minutes. There they go. Montana unloading. Looks like Purdue is heading back too. Montana just keeps unloading, keeps unloading, keeps unloading. Honestly, is that gravel? If that's gravel and it's not coming out, that is a real shame. Right now, with 40 seconds remaining in this run, Montana Tech has almost 32 kilograms on the scale. Purdue still at 11, but they're about to dump their second load. Purdue with only 25 seconds left. Hurry up, Purdue. Time is running out. 20 seconds. Come on, this is going to be cutting it too close to the wire. 15 seconds, Purdue. Come on, dump it, dump it, dump it. 10, 9, 8, 7, 6, 5, 4. 4 seconds to spare. Come on. They knew what they were doing the whole time. They timed that just perfectly. So these are unofficial results, but it looks like Montana Tech on the left-hand side ended up with more than 32 kilograms. Purdue University on the right-hand side ended up with, looks like 25 kilograms. Really great effort by both teams. Let's give both teams a big round of applause. You do not want to go anywhere. Next up, we have South Dakota School of Mines and Technology. We also have University of Alaska at Fairbanks. And right now, I have some jokes because I see some young members of our audience. How many tickles does it take to make an octopus laugh? Anyone? 10 tickles, come on. That was an easy one. 10 tickles. 10 tickles? 10 tickles? Come on. Yeah, 10 tickles. All right. This is my 13-year-old's favorite joke. There are two fish in a tank. One fish says to the other, "I'll drive, you man the guns." Let it sink in. I'll drive, you man the guns. They're in a tank. Yeah. They're in a tank. I'll drive, you man the guns. All right, but this is a two-parter. So there were two army men in a tank. One says to the other, that's they're in a tank, not a tank. Okay. Computer joke. Why was the computer cold? Why was the computer cold? Brr. We have a hand. She knows the answer. A virus? That's a good guess, but it was not the correct answer we were looking for. The computer left its windows open. Another computer joke. Why aren't spiders allowed on computers? They make too many websites. Yeah, websites. These are geek jokes. Speaking of geeks, how many programmers does it take to change a light bulb? How many programmers does it take to change a light bulb? None. That's a hardware problem. Yeah, we have a winner. Now my 11-year-old, this is his favorite. What's green and has yellow wheels? Think about it. What's green and has yellow wheels? It's grass. I lied about the wheels. Huh? I lied about the wheels. Isn't that a great joke? Nobody's ever going to get that one right. You can fool all your friends with that one. Are there any engineers in the audience? Yeah, engineers. Go engineers. To the optimist, the glass is considered half full. To the pessimist, the glass is considered half empty. To the engineer, the glass is twice as big as it needs to be. Re-engineer that thing. A lot of the students left. They would have laughed. The college students. They're right in the middle of engineering school. I'll say it again later when they all come back. All right, I have more. These are some jokes I told yesterday, but I know you weren't here yesterday, so you'll appreciate these. Why was the robot angry? Because somebody kept pushing his buttons. She keeps guessing I'm right. Have you been studying? Okay, why did the robot go back to school? His skills were getting a little rusty. Robot jokes. What do you call the robot that always takes the longest route? A robot that always takes the longest path. You call him R2 Detour. Oh, so many groans. So many groans. You are watching the 7th annual NASA Robotic Mining Competition being held here at the Kennedy Space Center Visitor Complex in sunny Central Florida. Thank you for joining us. If you stay tuned, you will see 2 more robots take the field. On deck, ready to go, we have South Dakota School of Mines and Technology. We also have University of Alaska at Fairbanks. Do not go anywhere.
We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
RC go. Somebody's go.
Payloads are go.
GNC go. Go. Prop go. AVI go. GNC go. Ground is go. GC go. Go. OSM go. Go for initiate terminal count.
STS go.
NASA CE go. 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 SMD is go for final count. BSC is go. Go.
Thank you for watching the NASA Robotic Mining Competition here at the Kennedy Space Center Visitor Complex in sunny Central Florida. You can see in the arena right now we have two teams getting ready for their run. On the left, South Dakota School of Mines and Technology. On the right, University of Alaska, Fairbanks. I think Alaska still has snow this time of year. Those poor students, they don't know what to think of Florida this time of year. Both of these teams getting ready to do their second official competition run. Both of these teams did do very well in their first run. Two very different robot designs. We have a wheeled robot and a tracked robot. Both of these robots are going to dig using bucket ladder systems. These teams are in the middle of their 5-minute setup period. They are activating all the systems on board the robot that are required, and they're doing some testing with their teammates in the control center. You can see their teammates in the control center on the video. On the left, South Dakota School of Mines and Technology. On the right, Alaska Fairbanks. The Alaska Fairbanks robot is capable of fully autonomy. We will see if they choose to use it or not. If a team is able to perform the entire task of collecting regolith, bringing it back to the lander and depositing it there, if they're able to do that the entire 10 minutes, fully autonomous, that is the holy grail of this competition. There is a huge bonus for doing that. We are streaming live all week on Ustream. Our URL is shown on the screen right now. So share that URL on social media and let all your friends and family know about this competition. I'm sure they would love to watch right along with you. My mother up in Illinois, she's retired. I wouldn't be surprised at all if she's watching right now. Hi, Mom. All right. We are getting down to the last few seconds of our setup time. All the team members have left the arena, and just like that, we have started the official 10-minute run for these teams. The judges were completely ready to switch over from setup time to actual competition time, and there you go. Oh, Alaska Fairbanks, climbed right up on that rock and fell over backwards. That is not something I think they can recover from. We're not going to let the team come back in here and right the robot. We're pretending like this is a real off-planet mission where we're remotely controlling this robot. So if that happened with a robot on Mars or another planet while we were controlling it here on Earth, we'd be stuck there unless we had some way to get ourselves righted again. That is a shame. That robot is very capable of digging quite a bit of regolith. Meanwhile, South Dakota School of Mines has made it through the obstacle part of our arena, and they are now starting up their digger. Looks like they're driving forward slowly as they dig. I can see some dust. And I can see some of those buckets as they come around the top on that conveyor belt are really, really full. This is going to be a real. There's no way for me to know how many kilograms are in that robot right now, but we're about to find out when they get back to the lander and dump it. The object is to collect this simulated regolith, which has precious material in it, and get it back to the lander. Are they having trouble driving? Their wheels are turning, but they don't seem to be making very much progress. The drivers in the control room will have to decide what to do. This is the view that they can see. They can see their wheels are turning. Okay, let's back up. That seemed like a good solution to me. While they're there, they might as well dig some more. Actually, they were probably just emptying their buckets. No, that's a digging operation. So, South Dakota School of Mines getting as much regolith onto their robot as they can possibly hold in this first trip. They still have 6 minutes remaining in this, their second and final official competition run. These students have been working all year long to design these robots and build them and test them. I'm not sure what just happened. The conveyor belt went down. They might have done that to change the center of gravity on their robot because looks like they're having a little bit of trouble driving on this regolith simulant. There's an image of the South Dakota School of Mines team, a live shot from their control room, and there's a live shot of their robot. They are offloading this regolith. that's got to be a tough decision to make. It's possible the robot was loaded down too much, and they had to. All right, watching the judge. The judge has got his hand on the emergency stop on the South Dakota School of Mines and Technology robot. We got a thumbs up from the... I'm not sure what that means. The red flag went up. So I guess this competition is over. Neither of these teams were able to get any regolith deposited into the hopper. That's a real shame because both of these robots are very capable. They had very good first runs. Let's give both of these teams a hand. South Dakota School of Mines and Technology and University of Alaska Fairbanks. Up next, you do not want to wait. You do not want to miss the University of Alabama and the University of Illinois at Urbana-Champaign.
Asteroid 1999 RQ-36 may hold clues to how life began on our planet, but it also may be headed straight for us in the year 2182. To better understand both the potential scientific and literal impacts of this 1,900-foot diameter asteroid, the Osiris Rex mission will give us a closer look. Osiris Rex stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. Scheduled for launch in 2016, the Osiris Rex mission will collect the first samples taken from this special type of asteroid, holding clues to the origin of the solar system and likely organic molecules that may have seeded life on Earth. Researchers will examine the RQ-36's orbit, explore its regolith, and examine the composition and potential for resources like water and metals. Osiris Rex will collect samples that will be useful for decades of future research. Once the samples return to Earth in 2023, scientists will be able to potentially reveal how life started on the planet. NASA Goddard Space Flight Center will manage the project and provide the OVERS Visible and Infrared Spectrometer instrument. Principal investigator Dr. Michael Drake, director of the Lunar and Planetary Laboratory at the University of Arizona, will lead the team.
Welcome back to the NASA Robotic Mining Competition. We are about to witness, on the left, the University of Alabama. And on the right, the University of Illinois at Urbana-Champaign. Both of these teams, veterans of this competition. The University of Alabama has actually never missed a year. They've been here all 7 years. The Alabama robot has autonomy, so it'll be interesting to see if they can pull off an entire 10-minute session with autonomy and beat a score that they could otherwise get manually. It's a tough decision whether to do autonomy, because if you're sitting there watching that robot perform autonomously, you're thinking in your head, I could do better than that myself if I was driving it manually. Is it worth it? All these decisions these teams have to make are a trade-off. On the cameras, you can see both teams in the control room waiting for the heads up from the judge to tell them that they're able to start setting up their equipment. And there you see the team stepping into the arena. That begins the 5-minute setup period for these teams. Alabama's robot is a wheeled robot design, a bucket ladder digger, and a conveyor. Digger in the front, conveyor in the back, a hopper in between to hold the regolith. U of I's robot is on tracks. It has a bucket ladder in the front, and instead of a conveyor, they have chosen to dump their regolith, just like a dump truck. You may be wondering why everyone in the arena is wearing all that garb, all that gear, for safety reasons. This regolith simulant that's inside the bin is very fine powder. It's crushed rock, but it's crushed very finely. When it gets airborne, it stays airborne. That's why the judges that are in there full time today have to wear respirators to make sure they do not breathe in any of the airborne dust, because the judges stay in there while the robots are operating and kicking up dust. Everyone is wearing a white suit to cover all the skin on their body, because this fine powder, just like talcum powder, can be a skin irritant to some people. The Alabama team is posing for a photo. They're ready to go. The U of I team has also left the bin, and so they're probably ready too. They're just communicating with their teammates in the control center to make sure that everything is working before they exit the arena. Any results that you see posted on the screen are unofficial results. Not only that, they don't take into account all the things that the official judges take into account, like how much the robot weighs and how much communication bandwidth the robot uses and whether or not the team was fully autonomous. Only the judges have visibility into that detailed information, so we cannot show you those sorts of detailed results until the judges go over all their paperwork that they've been keeping track of this week and post official results at the end of the day tomorrow. Again, the two teams that are getting ready to run. On the left, University of Alabama. On the right, the University of Illinois, Urbana-Champaign. Okay, both teams are exiting the arena. As soon as the judges put some final touches on the arena, they will give the thumbs up to the timing judge. You'll notice sometimes teams attach things to the lander being the side of the arena that the robots are sitting on. On the U of I side, you can see a checkerboard pattern. That's usually used by a robotic vision system. It could be used by an automated system, or it could be used by a manual driver to give them feedback about how close they are to the hopper, or whether they're lined up or whether they're crooked. I see motion. We have started. This is the second official competition run for both of these teams. Alabama's robot looking back and forth, trying to figure out where it is, mapping the field. This is fully autonomous. Alabama's robot is crossing the obstacle field, not having any trouble crossing that field. Once it gets to the digging area, it's going to lower its bucket ladder digging system. Again, Alabama on the left. You can see some dust flying. They're definitely digging. Is the robot smart enough to know just what angle to put that digging implement in order to maximize its yield? You can see it keeps lifting it up. It's moving forward while it digs. There, it's moving forward, lifting up. Oh, yeah. Yeah, it's getting some good regolith there. You can see it slow down a little bit when it starts to dig in. The spinning will slow down. Okay, it's done. It's decided it's going to go dump. Let's see how much Alabama has on board the robot right now. The robot has to align itself with the hopper and then turn on the conveyor. Oh, look at that coming out. That's a lot of regolith right there. University of Alabama heading back for another run. 2.5 minutes in. All right, on U of I side, we finally see some movement from this robot. Meanwhile, Alabama's back in the digging area for their second drive. Alabama has about 12 kilograms in the hopper from that first run. This Alabama robot performing better today than it did yesterday. You can see this cycle that it does. It puts the digger down, it drives forward, and then it backs off, and the digger goes up, and then it does it again. Three and a half minutes in, Alabama's going back to dump. Back to the lander. Meanwhile, the U of I robot, it got out of the starting gate, got halfway through the obstacle area, and stopped moving. Okay. I just saw U of I's digging system move just a twitch. So obviously the U of I students in the control room are trying to control that robot. Alabama robot got a little lost there. He's looking around. Is it a he or a she? He. Okay. Now the team is watching. The Alabama team is watching. Is it worth the pain to watch this robot go back and forth and back and forth? How long do they give it before they take over manual control? The robot appears to be nodding back and forth, looking for its location in the arena. Where is that hopper that I'm supposed to drive to? At some point, the students are going to give up. If this continues, they'll give up on the autonomy points. Right now, the students know that the scale is holding 12 kilograms on the Alabama side. Honestly, if this continues, this robot may end up digging itself down into a hole. Four and a half minutes remain. All right, something's happening on the Alabama side. Something may be rebooting, not sure. Are they going to let it go and get the fully autonomy points? They do have 12 kilograms, which qualifies them. Alabama students on the left, 12 kilograms in the hopper, and a robot that is not there. It's moving again. Kind of looks like we have hands on a keyboard, maybe. Hard to tell from the video feed. Only the judges know for sure whether the students are controlling this robot or letting autonomy continue to work. Okay, Alabama's unloading their second load. 3 minutes remaining. U of I have not seen their robot move in quite some time. U of I was able to turn their robot and get halfway across the obstacle area, which is a feat in itself. driving a robot on top of this Regulus simulate is not always easy. All right, Alabama's going to take another try, digging in. They're hitting it pretty hard there. But every time they do that, they're getting some. There they go. There they go. They found a happy medium there. They found a digging height. And they're going for it right there. The wheels. It'll get back to the other side pretty quickly. The students are watching the clock. 1:35 left. They decided that's enough. We need to make sure we have enough time to get back to the lander and dump this load onto the lander. 1:20 left. Alabama dumping quite a bit of regolith there. With 1 minute left, what are they going to do? Are they going to try and dig some more? Why wouldn't you? 1 minute left, 55 seconds. On the scale, Alabama has more than 40 kilograms. More than 40. All right, we have 40 seconds left. How much time do they need to head back to the lander and dump? $25 seconds. 20 seconds. And they're heading back. Only 10 seconds left. 9, 8, 7, 6, 5, 4, 3, 2. They were able to actually dump some. Hands off the controls. All right. So, after University of Alabama's second official competition run, they have 42 kilograms in the hopper. Congratulations, University of Alabama. Sadly, University of Illinois, Urbana-Champaign was unable to get the robot to the digging area. But very good attempt by U of I, Urbana-Champaign. Please come back next year. Up next, we are going to see Texas A&M International on their second attempt. We're also going to see University of Hawaii at Hilo for their second attempt. Don't go anywhere. You are watching the 7th annual NASA Robotic Mining Competition at the Kennedy Space Center Visitor Complex in sunny Florida.